Here's a short little video clip that might clarify what we're using the Servo project for that we've been making for the RV10. The idea is to use an electric knob to control the hot and cold damper for the heater instead of a push-pull cable. So here's a picture of the circuit board, and we drew up using 555 timers to send the pulses to control the servos. The little servos are radio controlled servos for an airplane. They're relatively inexpensive, and they have a unique characteristic of the way they operate. They need a pulse of a pulse width of 0.6 milliseconds to swing the arm one way, up to a 2.4 millisecond to swing the other way. And to achieve that, we've used the 555 timer and a timing circuit that sends out that pulse. It's not real critical as to how fast you send the pulse. It needs to be somewhere around some radios use 400 hertz and some use around 50 hertz. So anywhere in between there will make it work. And to power it for the test and build up of it, I have a little transformer on the wall and used it out of a computer. You can turn it on. Here you can see the servos. If we turn the knob, that's how we'll control the heat. And to kind of see what the pulses are doing, I downloaded a program on the computer that has, we use this input wire that is the same wire that sends the pulse to the servo, and it's hooked into the sound card on the computer. So the input of these pulses goes into the computer, and then the sound card uses that to develop a spectrum. And we'll turn it on. You can see here the square wave indicates each wave pulse that is sent to it, and the length between the pulses is how fast it's sending it as to how many hertz. So what we can do with this software is we can go over here, and you may not can see it on the camera, but we'll capture the scope, and it takes the information and records it, and then we get a graph here, and this is what the wavelength looks like. And if you'll measure from the start of one wave to the start of the next wave, you can see how fast it's sending the signals. So here, if we go over here and say that wave started there, and then the end of it is about approximately right there, that says it's 14.9 milliseconds. So from that you can figure out how many hertz that it's sending it. Now, if you want to find out how long the pulse is, on this one, see the pulse is only about 0.589 milliseconds long. That's when it's stroked all the way one way. We'll close that, and now let's stroke it the other way. And then capture the spectrum again. Now you can see that they're a lot longer. If you measure from here to there, it's about 2.4 milliseconds. So that's how we control the arm on the servo for where it's according to how much heat we need.